Good morning, students. We have already looked at two methods for improving the performance of TCP in traditional networks. The first method was slow start, and the second method was congestion avoidance. Today, we will look at the third method. So, the third method is actually comprising of two methods, the fast retransmit and fast recovery. So basically, these two methods are to be used concurrently or simultaneously or together. You can say they cannot be used independently. Okay, if you use it independently, it won't make much of a difference to the performance of the TCP. So let's look at an example how fast retransmit works. Okay, you need to know the concept of slow start before you start watching this video. So if you do not know the concept of slow start, make sure that you watch my previous video on slow start in TCP and then come and watch this video. So let's take an example and understand what is fast retransmit, and we will understand what is fast recovery. So looking at this example here, you can see that initially, the congestion window size has been set equal to 1. That means the sender transmits or sends one segment and waits for the corresponding acknowledgement to arrive from the receiver. When the acknowledgement arrives from the receiver, this is the acknowledgement that arrives from the receiver here. The congestion window is set equal to 2. That is, the congestion window is doubled. Okay, you know how slow start works. So basically, this is what is happening here is slow start. Initially, the congestion window is set equal to 1, then the congestion window is doubled. Now that means the sender can send two packets and wait for their acknowledgements to arrive. So the sender sends two segments across segment 2 and segment 3 and waits for the acknowledgements to come before the round trip timer expires. So you can see here that the receiver replies with acknowledgement 2 and 3 for the corresponding packets or the segments that it had received. So when the acknowledgements arrive at the sender side, the congestion window size is doubled. Okay, so this value of congestion window is now equal to 4. So that means now the sender can send 4 packets. So it tries to transmit. Okay, the sender tries to transmit segment 4, and due to some error, the segment 4 is lost. But since it could send some more segments also, since the window size is equal to 4, it tries by sending segments 5, 6, and 7. As you can see here, segment 5, 6, and 7 have arrived successfully at the receiver's end. So what this means is, since these segments 5, 6, and 7 arrive successfully at the receiver's end, it means that segment 4 has been lost due to some transmission error or due to some error, but not due to congestion. Okay, because if segment 4 was lost due to congestion, and if there was congestion in the network at this point, then since segment 5, 6, and 7 have been sent after segment 4, if there was a congestion in the network, even this packet should have been lost or they should have not been received by the receiver. But since they have arrived at the receiver's side, it means that packet 4 has been lost not due to congestion but due to some error. Okay, I hope I made myself clear. So since the receiver has not yet got segment 4, but it has got these segments 5, 6, and 7, it needs some way of telling the sender that it got segment 5 but not segment 4. So in order to do that, TCP has a mechanism wherein it makes use of the previously sent acknowledgement of the packet that was received successfully before the packet that was lost. So by that what I mean, Since segment 4 is lost, we look at the previous packet. Okay, the previous packet that was sent was the third packet. So you check whether the third packet was received successfully. Okay, it was received successfully, and it is received successfully. Check for the acknowledgement of the third packet. So the third packet is having some acknowledgement. Check for that acknowledgement of the third packet. So we see here that segment 4 has been lost. Okay, the third packet has been received successfully. So the acknowledgement for the third packet is this one, acknowledgement 3. So now what the receiver will do is, when segment 5 has been received successfully, in the ideal case, the receiver would reply with an acknowledgement for segment 5. So in the ideal case, it would reply, since segment 5 is received, it would reply with the acknowledgement for segment 5. But as you can see here, this is not the ideal case. The segment before segment 5, that is segment 4, has been lost. The receiver has not yet got it. So this is not the ideal case. So we cannot send the acknowledgement in this manner. Okay, that is, we cannot send the acknowledgement with the number 5. So what TCP does is, it makes use, in order to tell the sender that segment 5 has been received successfully, but segment 4 has been lost. It takes the previous acknowledgement. Okay, by previous I mean the acknowledgement that was sent before the segment that was lost. So the segment that was lost is segment 4, and the acknowledgement before that is the third one. So it uses this acknowledgement and it sends in reply to the segment 5. What it tells is, the acknowledgement tells is, since you're sending acknowledgement for the third packet or the third segment, it tells that the packet following this, that is segment 4, has been not yet received. Okay, and since you're sending this acknowledgement, the third acknowledgement, in response to segment 5, it mentions that segment 5 has reached successfully. Okay, I hope you're getting it. Similarly, when segment 6 has been received here, it checks for the acknowledgement before the segment that was lost. So since the segment that is lost is 4, and the acknowledgement before that is the third acknowledgement, it replies with the, for segment 6 also it replies with the third acknowledgement. When it replies with the third packet acknowledgement, what it means, after the third packet, the fourth packet has been lost, and since you are sending this in reply to the segment 6, it means that segment 6 has reached successfully. Similarly, the same process is done for when you send segment 7. If segment 7 has been reached successfully here, has been received, then again the receiver replies with a duplicate acknowledgement. Okay, so you replied with the duplicate acknowledgement. So again, like you must be understanding by now, since segment 4 is lost, the acknowledgement prior to that is used, which was sent successfully. So that prior acknowledgement is the third acknowledgement. So what it means? It means that segment 4 has been lost, and since it's sent in reply to segment 7, it means that segment 7 has reached the receiver successfully. So as you can see here, when the sender receives 3 duplicate acknowledgements, okay, these are the 3 duplicate acknowledgements, it indicates to the sender that the segment following this number in this case is the third, 3. So it indicates to the sender that the segment following this number has been lost. Okay, so in reply to that, when it gets 3 duplicate acknowledgements, it retransmits the lost segment. Okay, it retransmits the lost segment. And there is no need to retransmit segment 5, 6, and 7. Okay, so the advantage of sending duplicate acknowledgements is there's no need to retransmit the segments 5, 6, and 7. It because these acknowledgements tell the sender that those segments have reached the receiver successfully. So we end up in only retransmitting the lost segment and thereby improving our or helping with our bandwidth. So ideally, fast retransmit, you only retransmit the lost segment. Okay, and you do not retransmit the other segments that have been sent across successfully. So the other thing that you need to know is if in the normal case, if fast retransmit was used by itself I mean it was not used together with fast recovery, okay, then fast retransmit would change the congestion window back to 1 after retransmitting the lost segment. Okay, whenever this lost segment was retransmitted, then fast retransmit would invoke the mechanism of slow start and set the congestion window back equal to 1. So by invoking slow start or by making the congestion window equal to 1, what would happen is the network speed would be reduced drastically. Okay, since you can only now start again from the beginning. So in order to prevent the network speed from reducing so much, that is drastically, since only one segment has been lost, we don't want to reduce the network speed by that much. So therefore, in order to stop slow start from happening, we use the mechanism of fast recovery. So what fast recovery does is it prevents the congestion window from dropping to 1 every time some packet is lost. Okay, because every time the congestion window is restarted from 1, the network speed will decrease and it will take a lot of time to reach the high bandwidth speed that was as before. Okay, so fast recovery basically removes the slow start phase. So how it removes? Basically, whenever the segment is retransmitted using fast retransmit, fast recovery will reduce this window by equal to half. It will reduce this window by equal to half. So instead of going all the way to 1, so in this example here, the congestion has happened, the retransmission has happened during this time when the window size was equal to 4. So fast recovery will reduce that size to by half, so it will become 2. Okay, so instead of going all the way to 1, it will reduce by half. So suppose the congestion window was equal to 32, fast recovery will reduce that size by half, so it will become 16. Okay, so you can imagine if fast recovery was not there, so during this phase, if some packet had to be lost, then we would, if fast recovery was not there, we would start with slow start. Slow start means the congestion window has to always start with window size equal to 1. So because we are using fast recovery, whenever a packet is lost, we reduce the window size by half, so we can start transmitting 16 packets. Whereas if fast recovery was not there and only fast retransmit was there, then slow start would have to be used and the network speed would be reduced, as you can see here. Okay, so I hope you all have understood what I have explained, and thank you for listening, and see you for the next lecture.